How's it going, everybody? In this video, I wanted to cover another topic on the SP blueprint that I have only covered a handful of times in the past, and it's been a long time since I've covered it, so I want to kind of refresh the knowledge and whatnot. So, in the description below, there should be two links to a to a blog post that I recently did that covers this, the configuration, and then a detailed breakdown of what's going on and how it works and that type of stuff. So, carrier supporting carrier, or CSC as it's commonly referred to, is kind of it's a cool technique. It's similar in some ways to unified MPLS, which I covered in the previous YouTube video. So anything that's service provider specific, I've placed underneath the service provider playlist. So you'll be able to reference the unified MPLS video as well. The big difference between the two is with unified MPLS, you're in the same autonomous system for BGP. Here with carrier supporting carrier, we have two different ASs. We have the AS on the left and the AS on the right and the AS in the middle. The AS on the left and right, even though the document, the picture shows BGP1 and BGP3, that's actually not accurate. It's actually BGP 50693 on both sides, and then BGP2 in the core. Now, why this is different and significant is because when we talk about CSC, in correlation to what you saw with unified MPLS, what you're basically doing is you're taking a service provider that has a regional has a regional presence. So let's say, for instance, again, I'm from the Upper Midwest. So let's say Wisconsin, Illinois, Minnesota. Let's say, for instance, I run a service provider that has reachability in those states, so that tri-state area. So I can reach from, Chicago to Milwaukee to Madison to Minneapolis, St. Paul, that type of area. Now those are just major cities that I'm familiar with off the top of my head. There's other. I could have reached to Green Bay. I could have reached down to Springfield, or say Antioch, Illinois, or I could have reachability into, and I don't know many cities in southern Minnesota, but let's assume that that's my reach. But I also have reachability down in the eastern southeast. So let's say, for instance, Florida, Georgia, Alabama. So Valdosta and Atlanta, Tuscaloosa and Birmingham, or is it Birmingham? I think it's Birmingham. Then Orlando, Tampa, and Miami, and maybe Jacksonville. So I have two different portions of the U.S. I have the Upper Midwest and I have the Southeast. I think they'll actually be more like that in the screen. I could see my camera on another screen. But the point is, I have two regional service provider reaches. So, but they're not directly connected to each other. So, but let's say, for instance, for the sake of argument, we went out and we purchased the eastern southeast. So the Florida, Georgia, Alabama. What that basically does for us is we have customers that are in both locations, but they want, let's say we have customers that have offices in Milwaukee and Orlando, and we want to extend connectivity between them, which is what R2 and R4 are basically trying to simulate. So, but what we could do is we could do one of a couple things, and the next set of videos that I do, or I should say the next video that I do, will be a different technique known as MGRE L3 VPN. According to the Cisco, or the Service Provider Program Manager, this won't be tested on in the CCIE lab. But because of the fact that it's a technique that I've only read about, I've never deployed, I'm going to try it out since I've got the topology like 95% of the way there. It's just a matter of making a small tweak, and I'll be able to test out MGRE L3 VPN. So, but we have two regionally disparate, so they're disjointed, right? There's nothing connecting them in between other than the internet that we have. So one could say, well, why don't you just do a GRE tunnel and be done with it? That is that is a potential solution that you could leverage. However, that would be a different solution than what I'm going to show you here. Now, the solution I'm going to show you here is carrier supporting carrier. So what does that actually mean? What that means is we have our carriers that we're in charge of. So the smaller customer carriers on the end, which are 6 routers that are going parallel, or I should say horizontally, are the carriers that we support, that we're in charge of. But we need to be able to get connectivity between, say, Milwaukee and Orlando. But in order to accomplish that, we need to have something in between that's going to allow us the connectivity. Now, the easiest way for us to do that would be to go reach out to another carrier that might have a national reach, so a tier 1 provider. So we would be considered a tier 2 provider because of the fact that we have our own infrastructure, we own our own lines, or maybe you don't own your own fiber or DWDM circuits between your POPs, but the routers that are using those physical lines are supported by us. We run them. So we're a tier 2 provider. We're providing transport for a customer from one site to another. Now, inside of that geographic area, so let's say from Jacksonville to Orlando, we're providing that transport. But from Milwaukee to Minnesota, we're doing it as well. But we need to be able to extend that reach between the two different regional areas. To do that, we're going to reach out to a tier 1 provider, so an AT&T or some other large layer 3 VPN capable provider, which is what BGP2 here is in the core. He is a provider that's got the ability of going out and reaching out. Now, one thing that's not drawn here, which I'll go ahead and I'll do it now because of the fact that I'm right here, is there's actually a line. I'll go ahead and draw this out real quick. There's actually a line between here and here. Let me go ahead and bring the size of that down a little bit so it's easier to see. There is a line between XR4 and R12 because I wanted to test it out. I ran into some issues when I was doing it XR to XR, and I wasn't sure why I was having the issue, but I wanted to at least get a solution up and running because this is basically what I'm going to be using for a test bed for the CCNP Surface Spreader courses that I'm going to be coming out with. So what you see here is the results. Is I have set up the core carrier is an MPLS layer 3 VPN provider, and what he is doing is he is providing connectivity for the POP or the SP on the left and the SP on the right. Now the SP in the core here treats the other service providers just like a customer. So this interface right here in R6 and R11 and XR4, these are in a VRF pointing down to the customer carrier provider edge routers. So what you end up getting here, I'll go ahead and bust out my thing here. So this right here would be the, well, that's really big. Waiting for it to respond. Let's go 14. This is the CSC PE, right? So this is what this is. So it's the customer carrier supporting carrier provider edge, and this is the CSC CE. Now between these two, there's got to be some sort of communication between the providers in order to exchange labels. So these are BGP labels. It could be BGP labels, they could be LDP labels. It really doesn't make a difference what the labeling technique is, as long as it's a labeled path. So in the core here, at all the different cores that are LAN or IGP facing, they're all either LDP or some other labeling technique, segment routing, RSVPTE. It really makes no difference whatsoever. But what we end up doing is we end up getting communication set up between the provider edge routers. So What's actually kind of interesting about this whole situation is R5 doesn't peer with R6 in a VRF. He peers with the provider, so R6, as if he is no different than R2. So what does that mean? R5's interface to R6 is not in a VRF. It's simply just it's in the global routing table, and you form a regular IPv4 BGP peering between to R6. R6 forms an IPv4 BGP peering down to R5, but this guy is in a VRF. R6 points to R5 in a VRF. And then all we do is we add the send label command, just like we did in unified MPLS between the area border routers. Think of this as an area border router are two routers that sit inside of the same autonomous system. Here we're dealing with autonomous system boundary routers, or ASBRs, where we are bordering two different autonomous systems, but we're still forming an LDP, or I should say, we're exchanging label bindings with each other. The actual label distribution mechanism is irrelevant. LDP or BGP doesn't make much of a difference. Now there is a way to do both. You could do LDP or you could do BGP. I'm opting for the BGP capability, just because of the fact that it's the first thing that I tested out. You can do any type of IGP between R5 and R6 and go from there. However, you cannot, at least last time I checked, you cannot do anything but BGP labels on XR. This LDP plus IGP plus LDP between XR and an iOS box, I don't believe is supported. I haven't tested it out to be 100% sure, but all the documentation that I've read dictates that it's not. So you have a labeled path here. So this will be a labeled path. Now, when we talk about this is basically how this comes into play. Now, what I'm doing here on R5 and needs to be done is there needs to be some way for routes that are learned in here. So we're got to remember there's IGP and LDP here in this core. There's IGP and LDP over here in this core. There's IGP and LDP in this core. But what we need to do, so this is where the secret sauce of carrier supporting carrier comes into play, is we need to be able to get routes from here over to here. So between the two different regional SPs, they need to propagate their BGP. They need to propagate their routes to the other provider, to the other regional POP, or the regional SP reachability, or regional. I don't have a good term for it. The regional service provider, in order to allow the communication between the different SPs. So what I've done, and there's multiple ways of doing this. What I've done is on R5, I have, because of the fact that I've learned all of the loopback addresses, so the LDP router ID information, I've learned all of the router loopbacks on R5 through IGP, through ISIS. So what I did is I went underneath the IPv4 address family and I simply advertised them as network statements up towards R6. R12 is going to receive them. Okay, R12 receives them, and that's great. Now there are other ways of doing that. I could have redistributed IGP, so ISIS, into BGP, and I could have also redistributed BGP into ISIS. Well, that's a quick, dirty way of doing it. The problem with that, though, is unless you put in some sort of filtering, you're going to be receiving a bunch of routes that you don't need. All you need is the, at least when I did my testing, I needed the route reflector loopback as well as the PE loopbacks. That's it. Now, the reason I say the route reflector plus the provider edge routers is I formed a VPN-before IBGP peering between XR6 and R8. So what I ended up doing is on R5 is I advertised R1, R15, and R8's loopbacks into BGP on R5, and R12 learned them. What I did on R12 is I created a prefix list that matched on any route coming in as long as it has a /32 subnet mask. I then went and created a route map that matched on that prefix list, and then I allowed that to come inbound. So I redistributed BGP into ISIS as long as it would match that prefix. So that what that basically would do is that would allow R3 it would allow XR6 and R8 to form a VPN-v4 peering between them, and then what I would have to do is I would form a peering between R3 and R1. So if I go to R1, let me go to R8 real quick. If I do a show BGP VPN-v4 unicast all summary, I have a peering to R6 or XR6 right there, right? And that's exactly what my goal was. If I go to R1, I do a show BGP VPN-v4 unicast all summary. I have a peering to I see peering to R8, right? That's my next hop. Now I didn't form a peering between R1 and R3, but I'm learning routes from him. So if I come in here and hit the enter key, I'm learning router 3's loopback. I'm learning a route from, I'm learning R4's loopback from R3. But if I take a look and I do, I grab this route right here and I expand upon it, what I'm doing is I'm actually learning that from R8 and XR6. So what I end up doing is I take that and I go, okay, well, this is where I learned it from. But if you look right here, this is my next hop, but I learned it from router 8. So then I need to go to router 8 and I need to come in here, router 8. I come in here and I say, I learned this prefix, so this destination address from this particular next hop. But if I take this and I grab this guy right, that should work. I learned that from R6, or XR6, excuse me. So what I did is I didn't form a VPN-v4 peering between R1 and R3. I formed a VPN-v4 peering between the route reflectors in the given providers, and then that was reflected down towards the provider edge routers, which then allows the propagation of the routing information. Now, could you do this PE to PE and bypass the route reflectors? Absolutely. The problem with that, though, is it doesn't scale very well. If you've got hundreds of hundreds of provider edge routers facing customers, that doesn't scale. So I'm choosing to use the scalable method. And I did try it with the PE to PE connectivity. That worked as well. But I was like, truth be told, it had been a while since I had tested this. So I figured, you know what, it'd be a good time just to test this out and make sure that I know what I'm looking at. So from a configuration perspective, we do a show run section BGP. You look right here. I have advertised router 1, router 8, and router 15's loopbacks into BGP, right? And the peering between R5 and R6 is in the global BGP table, and I've set send label. So I said, you know what, go ahead and form a labeled unicast peering. So we do a show IP BGP neighbors of 164.56.6, and I hit the enter key. I have this IPv4 MPLS label capabilities advertised and received. So R5 and R6 are exchanging labeled unicast routes with each other. If I do a show BGP IPv4 unicast labels, I'm learning labels from R6 to get to R3 and to get the XR6. So with that being said, I do that. Now on the show run section ISIS, I am also redistributing BGP routes into ISIS that are matching on a route map. So I do a show run, or do a show route dash map, or route map BGP routes. What I'm doing is I'm saying I want you to allow them as long as they match the prefix list. So show IP prefix list of this guy. I'm saying go ahead and permit any route as long as it's got a prefix prefix length of /32. So I can type in here, type in detail. Actually, it's before this, detail. And that'll tell me that it's working. I've had 6 hits on it. So what I'm doing on R12 is I'm doing the exact same thing. On R12, I come over here and I do a show run section BGP, and I'm advertising router 3, router 13, and XR6 is loopbacks into BGP, and show run section ISIS. I am redistributing BGP routes into ISIS as long as they match that particular prefix list. So when I go to R3, for instance, and I do a show IP route, I am learning the I'm learning router 1's loopback, I'm learning router 8's loopback, and I'm learning router 15's loopback via BGP. What that allows me to do is show BGP VPN v4 unicast all. I have now going to have reachability. I'm not forming a VPN v4 peering between R3 and R1. I'm forming a VPN v4 peering with XR6, which is also a route reflector, and that is where I'm learning my routes. So what the workflow is going to be, R2 forms an eBGP peering with R1. R1's connection down to R2 over here is in a VRF. So we already have that specific configuration going on. R1 forms a VPN v4 peering with R8, who is a route reflector. R8 is also paired with R5, and R5 is another client. So they're route reflected. So if R5 advertises a route to R8, R8 reflects that down to R1. What ends up happening is by R5 propagating routes into BGP, those routes are learned by R12. So on R12, we go over here and do a show BGP IPv4 unicast. I'm learning R1, R3, and R8, or I should say in this case here R1, R8, and R15 via BGP. So then what I end up having to do is I have to take those BGP learned routes and redistribute them into IGP. Now there's other ways of doing it, but I'm not doing I'm not doing that currently. I believe labeled unicast is the other way of doing it, and I currently don't have that rolled out yet. That's going to be another thing that I test. So now that we have that, what I'm able to do is I'm able to advertise those routes into BGP, or I'm sorry, ISIS. So if I do a show ISIS database, you're going to see, in this case here, is that level 2 only? Yeah, there's only level 2. So here I've got my local, so here is, let's see here. Okay, I'm only going to see what I've, is there a verbose? Yeah, so here they, no, that's not true. Let's see. Right here. So I'm learning these routes from router 12. So I'm learning 8, I'm learning 1, and I'm learning 15 through that. And it is working. As you can see, it's from R12. I had to sit there and find it. It took a couple seconds. The ISIS database isn't exactly the clearest, but it is proving that I am learning those routes. They're being redistributed into ISIS, and therefore R3 is able to learn them. So I do a show IP route, again for ISIS. You're going to see that I've learned router 1, router 8, and router 12 into BGP, or into ISIS. And then I'm able to get to where I need to go. Now, that gets us end-to-end reachability. So now it's just a matter of saying, okay, well, can I reach where I've got to go? And the answer to that question is yes. So what I end up doing is in the MPLS core from R1 to R5. So this is R1, this is going to R7, this is going to R5. So this is my label stack. If we do on R1, if we do a show IP route, or sorry, show IP route for VRF CSC, and we look at this particular route right here, the 192.0.2.4, we're going to see that we have a label of 17. Now, this is what R3 allocated for R4's loopback. So we go to R3 and we do a show MPLS forwarding table for VRF CSC. We're going to see that for the route we learned from R4, so the loopback address, we allocated a local label of 17. So we do a show BGP VPN v4 unicast all and hit the enter key. We grab this route right here. We're going to see that we allocated an end label of 17. So I don't want to confuse anybody, but when you look at this label value here, and then you look at this label value here, they're the same. It's not, it's BGP is allocating the label for R4's loopback that R3 is learning, but because of the fact that the label space for BGP, RSVPTE, and for LDP all come from the same global label space on iOS boxes, they appear as though it looks like it's LDP. It's actually not LDP here, it's actually VPN v4 is allocating it. But what we end up doing is, because of the fact that that label has been allocated for a customer learned route, which is why you see no label here, what we end up doing is we take that value and we propagate that to R1 as a VPN v4 update. So this is why when we look in the routing table for router 4's loopback, that's why we see a label 17. So we see label 17. If we go to R2, that is why we see a 17 here. That's where we're trying to get to. And if you look, 17's across the board. 17's everywhere. This is the VPN label. This never changes, and it's maintained all the way through to router 3. And then it is eventually popped and uses the VRF-aware routing process to get down to R4. So if we look at the label process here, the 38, 28, 32, these are all transport labels allocated via LDP to get from where we are to where we're going to go. So from R1's perspective, if I try to get to, I know where I've got to go. So from a recursion perspective, I need to figure out, okay, well, how do I get to router 4's loopback? Well, it's being advertised to me via that. So if I do a show IP route for 192.0.2.3, I got a couple different ways I can go. I can go, it was advertised technically to me through router 8 because it's a reflected BGP route. Even though it shows up as BGP in the routing table, but I'm looking at the VRF aware routing table. Now, if I do a show IP route for router 3's loopback, it tells me I need to go, it tells me the outgoing interface. So I know I have a route to it. Now I need to do a show IP Ceph. So what am I going to use for a label value? In this particular case, it's giving me label values 38 and 25. So now if I do a show MPLS forwarding table for, I believe I can type in the route 192.0.2.3, it's telling me that the local label is 35, no big deal, but it's telling me to use label 38 or label 25. So that's basically the direction we're going to go. So we know we're going to go towards router 7 because we see 38 right here. So we're going towards router 7. We know that based off of this next hop IP. So all we have to do, really, from here out, is just follow this repeatable process. We know where we're trying to go. We just have to figure out what the next hop is. So we go to router 7, which is right here. We get to router 7, we do a show IP route. We're going to have MPLS labels in the core. We're trying to get to router 3. That's our next hop. So show IP route to router 3's loopback. We get that output, and we do a show IP Ceph for the same thing. We're going to use label 28. Label 28 gets us to router 5. Is that accurate? Label 28 gets us to router 5. We get to router 5. We do a show IP route to 192.0.2.3. We see a label 32. Show IP route, show IP Ceph for 192.0.2.3. We're going to use label 32 to get outbound. Does that match? It does match. It gets us to router 6. So we do on router 5, we do a show MPLS forwarding table for 192.0.2.3. We're going to go inbound label is 28, so that's label 7 set as the outgoing label to get to R5. R5 receives it. R5 swaps that to label 32 to get us towards R6. We jump to R6, show IP route for 192.0.2.3, subnet not in table. Now what do we do? Well, here's the thing. We're actually not in the right table. We need to do a show IP route VRF CSC and that same address. Now we have a value. Now what we're going to end up seeing here is we know that the direction we're trying to go is actually in the global table here, not in the VRF table. But we see this, but we need to point us towards this address. So from R6's perspective, we know that we need to get to that destination. So show IP route to get us to 192.0.2.24, which is XR4's loopback, and we say which way we're going to go with that. So show IP Ceph, and we're going to use label 22. Now what's actually interesting here, if you look right here, we see in the VRF aware table, we're using label 24,027. So our label stack is going to be, this is the transport label that has been allocated by XR4 to reach router 3's loopback. But we can't actually use that one as our transport label because we need to get through the provider core, or I should say the backbone carrier's label switch path in order to get back to our carrier's label switch path. So this is when we move from a 2-label stack to a 3-label stack. So 24,027 will be the transport label for the customer carrier, but label 22 is going to get the customer carrier through the backbone carrier's label switch or MPLS core. So you should see a 22, 24,027, and then a 17. So let's go look at that. We see to get to router 10, we're going to go 22, 24,027, and 17. And this process just keeps repeating and repeating and repeating itself. We go to R10. We do a show IP route to 192.0.2.24. We see a show IP Ceph for the same address. We're going to use label 24,008. Go back to R2. 24,008, 24,027. That doesn't change. The transport label doesn't change as you're going through the core. Now we go towards 134, so we're going to jump to XR3. So it'll be the first XR recursion process we have to hit. Everything else has been iOS. So we do a show route to 192.0.2.24. We have an outgoing path. It's OSPF intra area. Show Ceph to that same address. We're going to see that we're going to use, we're directly connected to XR4, who is the provider edge, so we get an implicit null. And our local label is 24,028, or I'm sorry, 24,008. So show MPLS forwarding table for 192.2.0.24. Forwarding for prefix. That's the command I'm looking for? I honestly don't remember. Or is it the exact prefix? Oh yeah, it's this 192.0.2.24/32 and enter. There we go. So 24,008 is going to be our transport label to get to our XR4. So when we look at this on R2, notice how 24,008 gets us there, but when we get to XR4, we pop that label. So this label gets popped, exposing. Now we're back to a 2-label stack. So we're down to 24,027 on XR4. So we get to XR4. Oh, I typed that in wrong. Show route. So where we're trying to go now is back in the VRF. So show route VRF CSC and hit the enter key. We're trying to get to 192.2.0.3. So show route for this. And it's a BGP external route. We're going to do a show Ceph for the VRF of CSC and that particular prefix. And we're using a label value of 24,027 has been allocated. So what we're going to do is we're going to go ahead and take that same value and we're going to plug it back here in R2. 24,017 gets us to R4's loopback. If we look at XR4 again, we do a show Ceph for, let's actually do this instead. We should have R4's loopback here. Or no, we're not going to. Because the core carrier doesn't care. So we're trying to get to this particular path. So what it's telling us to do is get yourself down to XR5, or in this case here it's going to be XR or router 12. Get yourself down to router 12. Show IP route for 192.0.2.3. Show IP Ceph for 192.0.2.3. You're going to use label 18 to get there. So show MPLS forwarding table for 192.2.0.3. We're going to use, is it 20? Yeah, so 20 to 17, and then the process repeats itself all the way down the line. So 24,027 gets popped. On XR4, it gets us to, let's do a show MPLS forwarding table for 192. Or is it VRF CSC for 192.0.2.3. Yeah, so 24,027 is the local label. Then we swap that to the VPN label of 20. That gets us towards router 12, which is why on 12, that's why we see label of 20 come in and take us from there. And then once we get to that point, we're back on router 12, and then we are a 2-label stack from 12 to router 3, and then we repeat the process until we're there. So we go to label 18, we go to router 9, show IP route to 192.0.2.3, show IP Ceph 192.0.2.3, label and via 39. So we're gonna show MPLS forwarding table for 192.0.2.3. We're gonna see label 18 come in, which is what we see here. Label 18 comes in and it gets popped as it goes towards XR or router 3 in this particular case. It gets popped, and that when it comes in router 3, we see 17 be received via VPN v4, and it's then the entire label stack is removed. So that's the process of going through and verifying how all this stuff works. So really, it's not a lot. It's between the providers, between the customer carrier and the core provider, it's a labeled path of some type, whether it's LDP labels or BGP labels. It doesn't make much of a difference. And then when the traffic is received by the remote end, you need to make sure that you're propagating routes from regional SP1 to regional SP2. So from Milwaukee down to Orlando is being propagated and being learned, so that in this case here we're using route reflection. It's a good idea to have the route reflection enabled so that you can easily form your peerings and you're not having to do multiple peerings. You set up one VPN v4 peering between your regional POPs and you're good to go. And that's pretty much the extent of it. Now, I'll caution you. There's a lot of other sub options that are available. So you can change up the label allocation method, how you propagate the routes, so on and so forth. Now, I'll be testing those out down the road, but I wanted to at least go through carrier supporting carrier again and hit it up and see what's going on with it, because the fact that it's been a little while since I've done it. But that really is it. Now you might see a second set of lines here between the routers, and that is when I go to test out layer 2 VPN. I will be testing that out here in the future, but I only have I've got MG area L3 VPN left to test, and then I'm going to go test option B and option C and D for inter-AS options, and that'll be pretty much everything in layer 3 VPN up to that point. And then once I've gotten that done, I'm going to flip back over to layer 2. I'm going to go do that again, because I feel like there's I jumped over some stuff the first time I went through it, and I want to test those techniques out again. And I've actually been pretty fortunate with the lab that I've had. I've been able to dig into it, and I don't rebuild it, or I don't reload the config. I will save the config, and if you look at router, I think it's a router 12. One of these routers. Show IP interface brief. I've got a lot of interface. Well, actually, that's a bad example. I've got a lot of routers that are reused. Actually, if I go to router 1, and I do a show IP interface brief, I have a lot of interfaces that are physically shut down. And I do that on purpose, because I'll take the router and I'll just create a new topology, and I'll just create new interfaces and go from there and get the routing in place. So instead of having to rebuild it every time, I use the same IP addressing structure for everything. So the 164 has become a pretty consistent one, and then I go through and I just numerically label the interfaces in between the routers so that there's consistency. So I'll know 164 is always a transit link, and anything 192.0.2 is going to be a loopback, which gives me way more IP addresses than routers that I could ever deploy. So that pretty much gives me the flexibility that I need in order to test these technologies out and stuff like that. So I have MG area L3 VPN, options B, C, and D to go through for inter-AS VPN, and that's pretty much it. Once I get through that, which I'm thinking it'll take another couple of weeks, then it's layer 2 VPN, another deep dive into that. Going to be a much larger topology. I'm going to start off with probably, because iOS XR V doesn't support layer 2 VPN in the data plane, only the control plane. So I'm going to go and test probably 10 routers, and if not more, for layer 2 VPN and see how that plays out. And then that'll let me be able to test out layer 2 VPN. And then once I have that done, then there's I actually want to get back to doing the workbook development, stuff like that. But I wanted to go through, and because I'm taking the written in June, I want to make sure I've gone through the material and understand the different processes and capabilities. The documentation has been a really big help. And doing these demos and testing things out, even basic demonstrations. I mean, this is not I would never consider carrier supporting carrier an easy configuration, but if you are already comfortable with MPLS layer 3 VPN in an intra-AS design, just create 3 of them like I did, and back to back to back, and then interconnect them like I have. So I still have to get the XR to XR one, the issue resolved. I'm not sure why it's not working, but I redirected to get another direction, and I'll figure that out down the road to see exactly why it's not working. But beyond that, at least it kept the forward progress. And I've done carrier supporting carrier in the past. It just was it was a basic breakdown, and I had only gone through it a couple of times. And I will continue to try out these larger designs. The only drawback with them is they're larger designs. They take longer to build. Um, I could go with less routers, but um, I figure if I get accustomed to building and troubleshooting larger designs, when I get to the CCA lab and I get a large topology, I'll be comfortable in that type of a design. So um, one of the things that it wasn't actually a technology that, or it wasn't a technical thing that kind of opened my eyes to that particular type of um, study, if you will. For most people that know me from in person, know that I studied jiu-jitsu on the side. It's a more of it's a hobby more than anything. I don't take it seriously. Well, not very seriously. But uh, one of the things that I follow is Gracie Jiu-Jitsu, and the Gracie's pretty much invented, well, Brazilian Jiu-Jitsu, I should say. And one of the things that one of the guys that runs the Gracie Jiu-Jitsu Academy now said that if you're accustomed to worst case scenarios and that becomes your normal operating environment is worst case, then when you're in a worst case scenario, you're going to be used to it. So if you're accustomed to larger designs and larger configurations, then when you're in that type of a design, you're not going to get freaked out when you see a large topology with a lot of routers. You're going to be able to fall back on your training and go, okay, well, I've been here before. And you're going to be able to follow a process you're already familiar with. And that's really probably some of the best advice I've ever heard, is if you're accustomed to being in a difficult situation, then it really isn't a difficult situation to you. It's just a situation you need to rectify. And that's basically how I treat this. So it is a large topology. I have no clue what the actual CCA service provider topology looks like. I mean, you can Google it, and you're probably going to get a lot of results, but I have no idea which ones are legit and which ones are just what people have made up. I won't know until I sit for the lab, but I first have to pass the written, which is my goal right now. So I create these topologies. Hopefully you guys can use them. There will be a link in the two links in the description, one to the configuration, another one to the verification. And I didn't go through the level of verification in the blog as I did here, because it's easier for me to talk about it and to show you than it is to actually go through and type it all out. But the blog helps to document the config, so I can always fall back and be like, okay, well, I did a better job this time going through and configuring it. So this way here, it'll be a lot more. It's going to be a lot more thorough, and that's the goal here with the blog post, is to at least have the configuration documented somewhere. So if I need to, I can call from it. But beyond that, guys, that's pretty much it. I wanted to make sure that I covered it in a fair amount of detail, and I'll go from there. But when we get into the CCIE track, we'll go into more details, configuration options. Right now, I'm just making sure that I understand the theory of what needs to be done and some of the back-end processes that need to happen. But that's pretty much it. So that's it. If you guys have any suggestions for what you'd like to see, or if you're cool with what I've got going on here, creating a topology and walking you through it, I did actually have a direct message comment that asking me why I wasn't configuring things in the videos. I was just showing you the result of the configuration. And the simple thing is I'm not trying. I find it easier to teach you, at least right now, from a working design. So I don't have to sit there and spend 10 minutes trying to figure out why something's not working. I'd rather take the time, configure it, do a blog post on it, and then walk you through the config in a working design, and then link the blog post to it. It just keeps the videos cleaner, at least in my opinion. So there's that. And then we're going to, like I said, we're going to cover several other L3 VPN capabilities. And then we'll take a look at more other options down the road as we go along. But that's pretty much what we have going on. Pretty straightforward stuff for the most part. layer 2 VPN, and then once I'm through with that, then I think I'm pretty much good. I might fall back to some IGP specific techniques just to try out some features, and then my goal here is to at least to refresh all the layer 3 and layer 2 VPN stuff, because that's going to be the core of the exam. And then I want to spend some time on multicast. I really need to go through and test that out and really understand what's going on and how it's working, and get that working so that they're functional implementations of how that stuff goes. I really need to do a deep dive of multicast again, because it's been a long time since I really got into the details on it. Once I'm done with that, then it's a lot of the what do you call it? Not the peripherals. Yeah, the peripherals, services and stuff like that, and other techniques and testing and stuff like that. But I feel like I'm in a pretty good place right now. I think I'll be ready for by the time June comes around. I'm in Orlando. So yeah, again, if you guys have any would like to see something covered, drop a note in the description below, or a comment below, I should say. And if you haven't already done so, give me a like, give me a subscribe, and we'll catch you guys next time. Thanks, everybody.